Hello dear students of +1 medical and non-medical respected teachers. So today I am going to discuss Kepler's laws of planetary motion and their application from the chapter of gravitation of +1 physics. So let us start. What are Kepler's laws of planetary motion? There are three Kepler's laws of planetary motion. The first law is known as law of orbits. Kepler's first law is known as law of orbits, which states that each planet revolves around the sun in an elliptical orbit with the sun at one foci. So planet P is revolving around sun in an elliptical orbit. This is the position of sun and this is the center of the orbit. So this position of sun shifts in two foci of the ellipse, and between this point P1 is close to sun and P2 is far away from sun. This P1 is called perihelion and P2 is called aphelion. So P1O is equal to P2O is equal to A. This is known as semi-major axis. You can take it A, or and this is known as semi-minor axis. It is taken as B. So x square upon a square plus y square upon b square is equal to 1, equation of ellipse. Now, this is first law, Kepler's first law, law of orbits, which is states that, I again repeat, the each and every planet revolves around the sun in elliptical orbits, with the sun at one of its foci. So this law is based upon inverse square law, because it depends upon the distance. Now, Kepler's second law of motion, it is also known as law of areas or law of aerial velocity. It states that the area swept out by the radius vector. Radius vector means the line joining the planet to the sun. Area swept out by the radius vector, that is the line joining the planet to the sun, per second is equal. In other words, radius vector sweeps out equal areas in equal intervals of time. And this area swept out per second is also called aerial velocity. So in other words, aerial velocity remains constant. So this is Kepler's second law of motion. So my statement, so if P1 to P2 during time t, this is the area covered by the planet radius vector, and then P3 to P4, this is the area covered by the radius vector during the same time t. Then S P1 P2 is equal to S P2 P3 P4, S P3 P4. In other words, aerial velocity, that is dA by dt, is equal to constant. This is Kepler's second law of planetary motion. To prove it, now from the angular momentum L, we have already proved as L is equal to 2m times dA by dt in rotatory motion. So angular momentum is equal to 2m, mass of planet, into dA by dt. dA by dt is called aerial velocity. And gravitational force, which provides a centripetal force, acts from the planet to the sun along the radius vector. That is it is a central force. Gravitational force is a central force. So angle between gravitational force, which acts toward the center, and radius vector, radius of the orbit. So they have angle of 180 degree, or they are opposite to each other. F towards center, R away from center. So therefore torque acting is given by R cross F, that is Rf sine 180 degree, and cap is equal to 0, because sine 180 is degree is 0. So therefore, tau is equal to dl by dt. The relation between torque and angular momentum is equal to 0. This implies L is equal to constant. So you can simply take as angular momentum of the system remains constant. Angular momentum of planet remains constant. So therefore, if L is constant, 2m dA by dt is equal to constant. This implies dA by dt is equal to constant. So this implies aerial velocity is always constant. So which is the derivation of Kepler's second law of planetary motion from using the concept of angular momentum. Third, Kepler's third law is known as law of periods. Since this elliptical orbit is very large, so we can take it as nearly circular. But R is the suppose semi-major axis. Then according to law of periods, it states that square of the time period of revolution of a planet around the sun is directly proportional to cube of the semi-major axis. That is, t square is proportional to r cube, where r is semi-major axis, or you can say t1 square upon t2 square is equal to r1 cube upon r2 cube, or you can say t square upon r cube remains constant. This is Kepler's third law of planetary motion. You can also derive this law using the concept that necessary centripetal force is provided by the gravitational force. So gravitational force is equal to centripetal force, that is g mm upon r square. Gravitational force experienced by the planet of mass m, small m, and r the radius of the orbit is equal to m r omega square, centripetal force. Or mm cancels, so omega gravitation has 2 pi by t in terms of time period whole square. So it will be, from this equation we have t square is equal to this way 4 pi square over gm into r cube. 1 r is here, r square into r is equal to r cube. Now since 4 pi square by gm is constant, so it means t square is proportional to r cube, or if we take small r is equal to capital R, semi-major axis, so t square is directly proportional to r cube, or t square upon r cube is equal to constant, which is nothing but Kepler's third law of planetary motion. So these are the three Kepler's laws of planetary motion. First, law of orbits. Second, law of areas or area velocity. And third is law of periods. You can remember, and it is very important. This is our application of Kepler's law also. We can deduce Newton's law of gravitation from Kepler's law. As omega is equal to 2 pi by t, and necessary centripetal force provide the gravitational force. Centripetal force is provided by the gravitational force. Centripetal force must be equal to gravitational force. So F is equal to mr omega square, or mr 2 pi by t whole square, or mr 4 pi r square by t square. So by Kepler's third law, t square proportional to r cube, or t square equal to k r cube. Substitute value of t square here. So F is equal to mr 4 pi square upon k r cube. 1 r cancels. Now 4 pi square upon k is another constant. Therefore F, that is gravitational force, is directly proportional to small m upon r square. Now, since force between planet and sun is mutual, so F must also depend upon mass upon sun. So F is directly proportional to mass of sun, or if we compare these two, F is directly proportional to mm upon r square, or F is equal to g mm upon r square, which is nothing but Newton's law of gravitation. So we can deduce Newton's law of gravitation from Kepler's laws also. So this is all about Kepler's laws of planetary motion. Till next video, stay tuned, be happy, all the best, good luck.